Hello, everyone. Today, let's talk about Bernoulli equation. The Bernoulli equation is a nonlinear first-order differential equation of the form dy dx plus pxy equals qx times y n power. Here, we assume n not equals 0. If n equals 0, we assume n not equals to 1. If n equals to 1, we know the equation becomes linear, which we told you last time, right? Okay, so how to solve this Bernoulli equation? First, we want to transfer this Bernoulli equation into the linear ODE, okay? Of course, first order linear equation. We let V equals Y 1 minus N, power of 1 minus N. After we defining this new variable, we can divide both sides respect to x. Then we can get dv dx equals 1 minus n. Here we minus 1 becomes y minus n power. Then y is x function dy dx, okay? Then the original is dy dx. We try to use dv and dx. We try to use a form of dv dx, okay? So we have dy dx equals right side, 1 over 1 minus n, y n power dv dx. Then in the original equation, dy dx become dv dx, okay? We divide by yn, we can get this form. Since v equals y 1 minus n power, then we can replace y fully to the v. This is the form of v's differential equation. We look at this. If this part we treat it as a ax, and this part we treat is a bx, then we can rewrite this part into dv dx plus ax v equals bx. This is a linear first order ODE we talked last time. Then we know how to do that. We use a mu x, make it to be an exact ODE, right? We rewrite it as a differential form. Then we can integrating both sides. This is exactly we told you last time. So we can solve this one in the form of function v. Remember we put v equals y 1 minus n power. Then we can rewrite this into y form. Then we get a final answer to the Bernoulli equation we are dealing with today into this form. Okay. Okay, let's go through an example. of the Bernoulli equation. dy dx plus xy equals y 4 power times e minus x square power, okay? So for this Bernoulli equation, first we know which one is px, which one is qx, which one is Bernoulli's level. We call n equals 4, okay? So we can copy exact we did in the general form into this exact real case. We can let v equals y 1 minus 4, that is y minus 3 power. Then we do a derivative to the v equals 1 over y3's power, which is minus 3 y minus 4 power dy dx. Then we rewrite the original dy dx into the v function of dv dx form. Then we substitute y equals v minus 1 over 3 power into the original form and simplify them, which we can arrive a linear first order differential equation, which is dv dx minus 3xv equals minus 3e minus x squared. Then we all know and we are very familiar with how to deal with the first linear equation, right? In this case, px equals minus 3x, qx equals minus 3e minus x squared power. Then we are dealing with integrating factor mu x. Mu x always equals e integrate minus px dx, which is minus 3x in this case. Multiplying through by mu x in replacing it into the substitute it into the original equation, we get this form, which the form, this is the equation of the Vx. Now we can use a derivative for what? For this equation, we know left side is derivative of v times e minus 3x squared over 2 power, okay? Then we simplify the right side. And integrating both sides over here, then we get this form. This is the form we can solving for function v. Then v equals the form on the right side. Remember, v is y minus 3 power. Then we can get the form of y in this form, which is a solution, general solution for the Bernoulli equation of this case. Now you ask me, what is this part? Can we integrate this part? We cannot integrate this part easily because this is ex squared, so it's not easy to do this part. Now we have a way to do Taylor expansion. We use Taylor expansion function for this e minus 5 over 2 x squared power. This is, if you are not familiar with, just go back, review how we deal with the Taylor expansions, okay? If you know this one, obviously this is a continuous function, then we can integrate the whole part. We can integrate separately and do a sum of all the parts of the integral. Then we can get this part. And this one we can integrate, right? Integrate is become the x 2n plus 1. 2n plus 1 here, okay? Plus C. Then finally, we just put back v equals, we put back y, okay? We use v equals y minus 3 power. We express the solution in the form of y, which is the original dy dx, original ODE. So this is the final answer for this case of the Bernoulli equation. Okay, today we have talked about Bernoulli equation. So next time we are going to talk linear differential equation nth order. Okay, so until next time, thank you. Bye-bye.